Hello there. I'm going to be doing this video today on measuring with a protractor. And this is one of those skills that oftentimes students have had before, but they might have forgotten how to do this. They might not really have used a protractor before, or they might have used it and aren't really using it correctly anymore. So just going to talk a little bit about some things that we can do for students to get used to using the protractor, how to use it properly, and some things that may come up as students use it that we need to be aware of, as well as some extensions for students who already know how to do it or get the hang of it very quickly. So let's begin. So the first thing that's really important is the type of protractor that you're using. Now, if you have a class set that's all the same, that's fine, but oftentimes students will have their own protractors, and it's also important to make sure that students know how to use different types of protractors, so the reason behind why they work is going to be really important. So here's one kind right here, and for this one, we see that the 0 and the 0 are here, and this is what students are going to have to look for. And then their vertex is going to be at the center, right between where the two zeros are. So in this protractor, it's going to be above this line here, right where this mark is here. So they're going to have to use it there to measure angles. Here's a second protractor, and here our 0 and 0 is down here. And so our line that we're going to be using is this mark right here on the bottom. So you can see right away, using these two, they're going to be done very differently. So students need to be aware of that. I have a third one here, which is the one that I will be using today, where it's not at the top or the bottom, but it's actually kind of in the middle here. Here's the zeros, and there's actually a little round sight here. And so that's where the vertex is going to go. So when we use the protractor, we need to let students know that wherever the center is, that's going to be where our vertex is. And it's always going to be between the 0 and the 0. What we're then going to do is we're going to line up one side of our angle along this line here. For this protractor, that would be along the top. For this protractor, that's going to be along the bottom. And then we're going to need to read where the second side intersects with our angle measures up here. Now, one thing that we're going to notice right away is that there's actually two different sets of numbers to use. Here we have 0 to 80, and then 90 at the top, and then there's the obtuse angles 100 to 180 here. And they actually are going in opposite directions. And so one thing that is often confusing to students is which number do I use? And this is one where you could come up with some rules for it, but really we just have to use common sense. And that is the idea that before we measure, we should know whether it's an acute angle or an obtuse angle. And if it's acute, then we're going to have to use the numbers that are less than 90. And if it's obtuse, we're going to have to use the numbers that are greater than 90. And I think that's the only rule that we should really let the students know, is having them actually think through it and use some common sense to find those angles there. So here we have an acute angle. And so we're going to take our protractor, we're going to line the center up right here. And this is an example I could do with the students before letting them work on their own as well. We're going to line up this one side of the angle with our line. And now we're going to read and see what number that this goes through here. Now, my numbers are a little faded, but this says 60 here, and so instead of the 120. And it's actually 2 degrees to the right of that. Now, oftentimes students will go 60, 61, 62 and call that 62 degrees. However, when it's not exactly on an angle measure, we need to see that this is 60 and here's 50 over here. So it's going to be between 60 and 50. It's 2 units closer to 50 from the 60, so that makes it 58 degrees. So we're actually going to have to subtract these two here to make that angle 58. Now for this one here, probably the easiest thing to do again is make sure that we have the vertex lined up here. And now we're going to use this side of our protractor to line up the angle. And it looks like this goes right through 40 degrees right there. So there's an example of having an angle go in the opposite direction there. So now we're going to measure this obtuse angle, and notice how we have it in a different orientation. We don't have any horizontal lines here, so students are going to have to choose how to move their protractor. Now, of course, they could just turn the paper diagonally to make one of these sides the horizontal if they want, which they're perfectly free to do. But we could keep it in the same orientation and just turn the protractor. So if we decide to use this right side here as the base, we see that it's going to be about 113 degrees. And if we measure it from the other direction, we're also going to get about 113 degrees. So that's not a bad exercise either for students to do, is to measure it by using both sides as the base alternately, and then seeing if they get the same answer there. So because it's an obtuse angle, they have to make sure that they're using the degree measures that are larger than 90 rather than the ones between the 70 and 60 here. So after students have some basic practice, we can move on to some more challenging work for students. Now, again, some students might already know how to do this, and they might find that initial work very boring and not very challenging, so we can move them onto this work right away. And this work for other students, once they get caught up and they really know how to use the protractor well, then they can go to exercises like this as extensions and challenges. So for this one here, I do have it in a different orientation, but that shouldn't really be the challenge at this point. The challenge is that these lines are really very short. And so even if I line up the vertex correctly and the side, I can't tell where this is going to match here. And oftentimes students will try to eyeball it or do other things. But the easiest solution for us is going to simply be to extend these sides of our angle to be longer. And now that doesn't change the size of the angle, it changes the length of the rays, but that's going to keep the same measurement no matter what. So here we see this is going to be an acute angle. Here's the 50, here's 55, there's 56 right here. Something else I should just mention is that this does have half degrees way down here, and these are the whole degree marks, and the 5 is a little bit longer. So we do want to make sure students know which lines they're using for the degrees, and if some of the protractors have half degrees or even quarter degrees, we want to talk about that with the students at some point as they're doing this. So that's one variation students can do. Here's another challenge. Here students are to measure the reflex angle, or the angle that is larger than 180 degrees. And notice for this protractor, it doesn't have angles on it that are larger than 180. So what are students to do? Well, they have to use a little bit of knowledge of the fact that in a full rotation, there's 360 degrees. And they can't measure this angle here, but they can measure this one on this side. And so if they measure this angle, so this angle is about 228 degrees. Okay, so here we have another angle that's larger than 180. What makes this more challenging, it's actually larger than 360 degrees. So we start here with our rotation. We've rotated all the way around one full time for 360, and then we have this little bit here that's left over. So we know just from the diagram that getting from here to here is 360. And then we're going to have this little bit left over. So we are going to measure this angle here, and that's about 34 degrees. So we have a full rotation of 360 plus a little bit extra of 34. That gives us 394 degrees approximately for that amount of rotation. So thanks for watching. I hope you enjoyed the video and found it helpful. If you're interested in additional resources and more work with angles, I'll put a couple of links in the description for you for some workshops and books that extend on these ideas and give more information and can keep you going in the classroom with your work. So thank you very much for watching, and we'll see you next week.